Hi, my name is Nirbhay, and I'm a CS major at Cornell.
Hi, I'm Pranav. I'm a CS and math major in College of Arts and Sciences.
Hi, I'm Aditya. I'm a Math and CS major in Arts and Sciences.
Yeah, and this is our final project for EC3140. And the title of our project is a gravity compass. And a brief overview is that um, it's a compass that utilizes the onboard accelerometer as well as an external LED strip to point in the direction of true down relative to the board, or rather the direction of the force of gravity acting on the board.
Some uses include in space or in VR worlds where it may be hard to tell where true down actually is.
Yeah. So just a brief overview of how we get the direction data is that the directional data from the accelerometer is interpreted, and that's what we actually display on the LED strip, which is arranged in a circle around the device, and each LED corresponds to a potential downward direction. And since we have 60 LEDs and 360 degrees, that sort of approximates out to 6 degrees per LED. And I can talk about the specifics of the code.
Right. So we use a function that translates the accelerometer readings in the XYZ directions to a bearing between 0 to 180 degrees that corresponds to the direction of true down. And then to display a bearing between 0 to 360 degrees, we display both the previous angle that we get from the formula we outline in the on the GitHub, and we add 180 degrees to it to get the angle that to get the bearing that is diametrically opposed to that angle on the board on the external on the circle here. And yeah, so we use the PID timer to get the accelerometer readings every tenth of a millisecond, and then we use that angle. We use that formula to calculate the angle and display that angle on the external LED strip using the Lab2 code.
So just a brief overview would be we take the readings, we apply the formula, and then we output it on the LED strip. And now Nearby can go into a demo on our gravity compass.
With the phone. Absolutely. So running the demo here, you can see that. Just give a second to start.
And
you can see that the red LEDs on the external LED strip approximately correspond to the direction of the force of gravity acting on the onboard accelerometer. So this is one part of the red LEDs, and the other part should be diametrically opposed to this.
And another thing to note is that the other LEDs are given a color based on their gradient, and we tested this incrementally essentially by first seeing the accelerometer readings, and then we realized that they were noisy, and we were trying to do smoothing, but this was causing lag in our final product. So we essentially just lit up the two LEDs as mentioned earlier, surrounding it to indicate relative direction. And another issue in terms of testing was that initially we tried using magnetometer, but given external libraries, it was a little bit difficult to use that, so we had to resort to an accelerometer.
Yeah, and if you notice, there's 5 LEDs being lit up here, and only one of the LED corresponds to the actual angle, but we decided to light up 2 LEDs on either side of the actual LED to
Offset noise.
account for any noise in the accelerometer readings as well. Yeah, and I guess that's it for our project.
Thank you so much.
Yeah.
Thank you.